So yeah, we are going to talk about using ArcGIS for VR and AR applications. That's me, Pascal. I'm the director of the R&D center in Zurich, where we do the 3D JavaScript, CD engine, and also some VR stuff like ArcGIS 360 VR. Then there's Eric. Eric is filming. He's the product manager of CD Engine and 360 VR and GeoPlanner. Then we have from the runtime team, we have Rex, product manager, and our super virtual reality, augmented reality developer, Adrien. So. Very quick overview. So I'm going to talk first about terminology basically, so that we are all on one page. Afterwards, Rex talks a bit about like what are the actual use cases of VR and AR, and then Eric presents Esri Labs project 360 VR, which is a mobile VR solution. Then afterwards, I talk a bit about like how to bring in data into Unity. From CD Engine, and then at the end Adrien is going to make some pretty awesome demos where you can really basically develop your own stuff with ArcGIS Runtime. So let's start. First, VR versus AR. What is it? Virtual reality, augmented reality. So basically, just that we are all on one page here. So virtual reality is all about basically being there. It's about full immersion. It's about you go to another place. You're totally disconnected from your outside world. And yeah, so means you see a typical like a serious application, but obviously games where you actually really are in a virtual world which doesn't exist are basically that's virtual reality. Then, how we define augmented reality, here it gets a bit different. So everybody knows Pokemon Go. So Pokemon Go was basically the breakthrough for augmented reality. And now what's coming is more and more that the devices will be much more capable of positional tracking, and so you can have your device. And so, for example, the Tango stuff from Google can have your device, and it really understands exactly, and it's basically inside out positional tracking. So these devices will pop up more, and I think everybody knows that this is going to be a pretty big thing, especially of course in the GIS world, where you have everybody has a phone and a tablet. Then mixed reality. Here you see Adrien. The HoloLens, Microsoft HoloLens, I guess everybody knows it, where it's basically, you have your headset, but only parts are overlapped with computer-generated imagery. And this gives you a mixed presence, and the HoloLens is really a fantastic piece of technology. And I think in 2 years, a new one will come out from Microsoft, and probably that will be pretty huge then. So, to sum it up, it's all about immersive computing, and I think we are really start here, as we are at the baby beginnings of this basically new age in computing. It's really kind of like a fundamental change in computer-human interaction. I think it's like the same thing as Steve Jobs did with the Macintosh. Like suddenly you have a totally different interface. And of course, there are still things which need to be figured out, like the terminology. So the marketing people, they will stay confused in the next 2 to 3 years. It's complicated with like 360 imagery, VR, AR, MR. It's pretty complicated, and people are confused. But we really try to make, at least for us here, define this a bit. So. Very quickly, a bit terminology. So first, experience. In VR, when you talk experience, you typically mean basically app. It's the content, so it's not like the user experience, it's like really like I download this experience, I went into this experience in VR. So it's also the, for example, here you see the Oculus Rift store. It's not an app store, it's an experience store, basically. Next thing is mobile VR versus console VR versus desktop VR. It's also one of these definitions. Mobile VR means, yeah, you have your phone here and put it onto some pretty cheap headset like this, and then can walk around. So everybody has a phone, so broad reach, however, of course, limited, and then you only have 3 degrees of freedom, so you only can look around. But when you walk around, this guy does not get it yet. Actually, we figured out. So then we have console VR. This is actually at the moment the one which works well. It's the PlayStation VR. However, this is kind of a walled garden model. Like, yeah, you need to go over PlayStation, over Sony. And then the real thing, the desktop VR, this is like the really good user experiences, but they come at high cost, complex setup. And this is really like still like this kind of HTC Vive kind of setups. They are complicated to set up, but once you have it, it's really, really a great user experience. Then here, what's also interesting is that for the first time you actually really need to think about, like, is the user of my application, like, is he sitting or is he standing, or how much space does he have? So when you have room scale VR, this means this actually one problem is of the whole thing is you need a free room in your apartment. So this is like typically people don't have just a room for some VR experiences. So here it starts basically like yeah. But yeah, so in room scale VR is actually the coolest thing, that to actually really experience VR when you can walk around in like maybe your 3 to 4 meter area and really experience your for example, you have a car maybe, and really walk around it. Then however, typically your virtual worlds are bigger than 3 to 4 meters. You want to move around in the stuff. So, and however, the problem there is that moving around gives you motion sickness. So it's really a big problem that people they get dizzy. So what became now the standard for moving around is teleportation. That means you look at something and then you teleport there. So that's basically all what you do then. And also here, or for example in the Vive, you have your hand controller and then you point where you want to go and then you click, you go there. So this teleporting, that's basically really kind of what most do. So here we actually have numbers. So what's interesting is about half of the experiences, they actually they avoid to move around. They avoid locomotion at all because people don't like it. And then about 40% use teleportation portal, and then only about 5% use artificial locomotion. Means, for example, they have a gamepad like here, a Sony one, and then you move around and move around there. However, it's really a problem. Like, for example, you do something like this, and then when, for example, acceleration is a problem in VR. People don't like to be accelerated, or roll. Like there are many VR experiences where you cannot look at stuff like this because they know, like, when you can do like that, like roll your head, people get dizzy. So it means it's pretty weird for me, which kind of has to study that thing. Like, you make like this, it's like, so yeah, they really try to help in this that you don't get dizzy. Then last but not least, the big differentiator between vendors are input devices. So on the left side we have the hand controllers from HTC Vive, then from the PlayStation, which are a bit less accurate. And then it's also interesting here is also mobile VR devices are getting small hand controllers. And then Leap Motion is interesting. They have basically a sensor on top, and then they detect your hands without anything. And then there are treadmills, like really military guys to run around. So yeah, pretty exciting stuff here coming. So yeah, that was my quick introduction, and now I give it to Rex.
Fantastic. Thanks, Pascal. Great. So I want to kind of build off of that and talk a little bit about market potential with respect to trends really in the VR/AR market at this stage. This is separate from working within GIS or the geospatial area or Esri Technology related issues or sectors. So this is going to be a little bit small on this screen, unfortunately. Basically, there's a couple different areas here I want to cover, and that is really market trends within the use of VR and AR and what different enterprise, public sector, and consumer markets that are forecasted at this stage, because we really do have to kind of think about what different areas or industries are going to be working with VR and AR. In this case, we do see that there's a sizable chunk based on this study. By 2025, we're looking at a $32 billion market with respect to VR and AR. In the enterprise sector, we're looking at a variety of different applications within healthcare, engineering, real estate, retail, military, and education, right? So a variety of different capacities. Obviously, on the consumer side, we're looking at more entertainment and, in a way, educational experiences there. But we can see that there's a quite diverse potential here just within the VR/AR market by itself. Now, if we take a look at VR headset market share, we can see that today, or at least in 2016, a lot of the, with respect to the market share for different VR headsets that are designed specifically for VR experiences, we can see that there is a distribution between the different type of headsets that are available based upon cost and experience. So obviously cardboard is actually relatively low cost, so it's quite pervasive. It's easy to distribute, it's easy to create. You're usually using a mobile device that's available to the consumer, and they can take advantage of a VR experience right away. There we go, as Adrien holds up cardboard. Quite cheap, right? So you might see these things skinned in a way that advertise a specific customer or organization. There's others that are mixed in with this market share with respect to 2016, and I'm going to expand those out, just ignore cardboard at this point, and these tend to be higher end systems. These are desktop VR experiences, or it's maybe a better experience with a mobile device or a higher end mobile device such as GearVR, which we'll actually take a look at here shortly too. What's interesting is that if you're looking at some of the desktop VR headsets, such as HTC Vive or Oculus Rift, what we found is while there might have been a lot of potential in the market for, let's say, Oculus Rift, what we've seen is that the experience with HTC Vive has been better, and so they've really sort of outpaced their original estimates because a better experience, basically the ability to work with room-based VR and handsets to be able to interact with a VR experience much more immersively. Last thing I want to cover here is revenue. So really targeted from a VR/AR market trend as a whole, what we see here is from 2016 to 2020, we're really looking at a significant increase in the amount of revenue generated from the VR market. Initially, we're looking at a lot of revenue from the hardware market, but as we see software built to be able to power or work on these different hardware devices, that software is going to enhance and then basically overtake revenue within the VR market. Now, if we take a look at maybe augmented reality versus virtual reality, what we can see here is that there's an estimation that with augmented reality and being able to use or leverage existing devices to really augment your experience instead of having to buy a separate device or work with a separate headset, what we can see here is that there might even be 4 or 5 times greater potential for revenue within the augmented reality space. And so something to keep in mind. It's very interesting to see. I know that there's some folks out there that are already working within the augmented reality space, and good to hear, good to see that actually. So we'll see how that goes. These are some forecasts. Now, we've worked with a number of customers over the last year and a half, and we've seen some market trends actually with respect to VR and AR. With respect to VR, we see a lot of folks actually interested in being able to leverage VR for education, for planning, for training situations. They like the mobile technologies because it's cheap, right? They can distribute Google Cardboards to a number of their customers or their employees, and they can achieve what they need quickly. For those that need something a little bit more immersive and a little bit more rich in the experience, they're looking at desktop experiences. So instead of being able to, in one scenario, having to travel to a physical site, they could actually provide a nice, immersive, rich desktop experience using a desktop VR and provide the best experience possible to get a true, rich, and full experience. With AR and MR experiences, augmented reality and mixed reality experiences, we see a lot of applications within field operations. People are in the field, they're taking their mobile devices in the field. They want to be able to use and leverage or augment their experience in physical reality. They overlay virtual objects and content. Obviously within the handheld market, within AR and VR, being able to use something that you can hold in your hand, something that you have today at your disposal, such as iPhone, iPad, Android tablet, Android phone, something that you can use and leverage effectively with your authoritative geospatial data, represented accurately and overlaid on top of what represents a physical reality, likely through a camera feed. That's a very attractive approach to being able to use AR and VR. This also applies to different resource management and planning experiences, right? So not just working in the field, actually, but being able to visualize what might happen or what structures might be built or maintained within the field as well. So head-mounted devices, while today aren't necessarily wearable devices, you put them on with purpose. You're not really going to wear a HoloLens around for the entire day. Actually, technically, it's not really designed for outdoor use yet, but what we do see is that there are folks who would like to use this really at a small-scale collaborative fashion when looking at plans or schematics associated with their GIS data. Eventually, we'd like to see the technology advance to a point where we can make this more of a wearable device that you can use in the field, and you can supplement those field operation and resource management experiences. Great, so let's take a look at maybe some scenarios here that relate to some of these common areas. So I've listed a couple of different common scenarios we've encountered. I'm not going to go through every one of them, but they really highlight some of the areas, the industries that we find in the GIS market. We find a lot of interest in providing solutions, VR, AR, and MR solutions, right? So for example, with education, being able to show or demonstrate and educate users on time series data within or of natural phenomenon associated with climate change or a climate phenomenon, and being able to immerse into maybe, let's say, a rain shadow of a hurricane as it moves through the South Atlantic, or being able to communicate with constituents about infrastructure changes, and being able to get that information out and make it immersive and easy to access for constituents. In the planning area, maybe looking at new development plans, not necessarily simulating those plans and changing simulating your location, but actually going into the field and being able to visualize those changes in the field too, or collaborate with people in the back office to be able to see those. Training is pretty critical, so being able to deliver an application that allows for individuals to train, let's say in this case, agents that are going to be protecting VIPs, right, and being able to plan for situations where they need to be able to get an experience on the ground when they're not there or before they're there on site, or being able to prepare first responders, firefighters for wildfires that may occur, and being able to experience that virtually before they actually have to experience in reality. And then, in addition, field operations. This is pretty critical for a lot of folks that are working with AR. Is being able to visualize their infrastructure, their spatial data effectively and accurately, and then interact with that data in a coordinated fashion. Last slide here is really customer trends. So, in all this interaction that we've had over the last year and a half, there's been a few trends, right? And this is really designed to make you kind of understand that you're not alone. If you're still kind of feeling out what you want to be able to do with VR, AR, and MR. There's a lot of folks out there that have access to a lot of rich geospatial data. They have applications that exist today. A lot of them are already Esri customers, but they're still trying to feel out exactly how to leverage this technology. Some folks have actually advanced a little further, and they know what they want to do, and they're looking to build it today, right? But a lot don't necessarily know. They're really just interested, and maybe there's some folks here that are actually just interested to find out what we're doing and what they can do with their data today. I have to admit, everyone's been positive. Right? Everyone's excited about this. That's a sort of a general market trend. Some folks have even volunteered time, money, effort, right, to be able to make this happen. That's great. There's obviously some enthusiasm here, which is great to see. Unfortunately, some folks have actually started looking outside of Esri, right? Now, granted, there's a lot of different players in this market, but we want to make sure that you, as Esri customers or prospective Esri customers, are going to get solutions that you need to be able to work with your data and do it your way. Great. So with that, I'm going to hand it off to Eric, and he's going to take us through some of the technology.
Okay, so I wanted to introduce you to ArcGIS 360 VR. It's a mobile VR application that we pushed out at the end of last year. We designed it really focused on the urban planning space. So people were coming to us and saying they wanted a way to make kind of more engaging and immersive way to express potential designs. So if I'm a planning department and I've got 6 design alternatives, I want to actually be able to put people on the street and allow them to look up at those design alternatives to understand the scale, like as if they were standing there, to put themselves on the balcony of the adjacent building and see how it would impact the view of the view, for instance, of the mountains. So, you know, it was coming out of this kind of urban design space, but we're seeing now that it's out there, people have interest in using it in a lot of different ways. The real estate folks have really taken to it for doing kind of virtual tours of spaces that they want to sell. And actually some of the facilities folks have been shown some interest in it and using it as a way to put people in spaces and strip off walls and show interior features. And I'll actually show some of those examples. But the core about it was being able to, you know, on a mobile device, very, very quickly show people from a perspective and switch between different design alternatives and scenarios. And so what I want to do is actually just show it to you. It's the easiest way. So this is a browser-based viewer of what is called a 3VR file, which is what the file format of 360 VR. I'm going to use it to teach you how to use this, and then I'm going to pass this around so you can actually take a look at it. So looking inside the scene, when I've got the goggles on, I can of course look in many directions, any direction I want to. What happens is the viewpoints that you can look from are actually represented by these little blue cameras. And I've got a little dot, kind of like a crosshair in the view. And if I look at it and I click on that, I'll actually go to that perspective. So this is how I can zoom and move around the scene and actually look from different perspectives. Now I also will have on the bottom this little picker, and it's basically controlling the visibility of the scenario or the state that you're looking at. So for instance, I could drop in a new proposed building, right, and say, okay, this is what it's going to look like, this is what it currently looks like. And you can have many of these states. So for example here, I can drop in a representation of a visibility analysis of this proposed building on all the surrounding buildings and terrain. So it's not just photorealistic, it's actually your GIS information as well that can be stored in there. So with the device, the way you click on something is you tap this button on the right side here, this big round one. Now right above it there are 2 other buttons. One is back and one is home. If you hit those, you'll go back out of the experience or back to home, so you won't be able to look anymore. So just be aware of that. So just look around. This is an example of a building, and you can pull the walls off of it and strip it down to its HVAC system. So I'll give that to Pascal to hand out. Okay, so what is it? So we have the 360 VR experience and the 360 VR viewer. It's a new format, 3VR. It's composed of multiple rendered photospheres. So we're actually taking photosphere renderings at different observer locations. We manage all those locations. We create the observer points in the scene. You can switch between them with that visual bookmarking. There's also a picker on the bottom that allows you to pick a starting point. Each location can store multiple states like design scenarios, and you can switch between those scenarios. Right now it's created from CityEngine. We started producing these CityEngine 2016.1 last year, and we have a vision for moving that so that we can author it from other applications eventually as well. And for now it's viewed in the Samsung Galaxy VR. And we're going to be looking at expanding that to other devices and actually making a web app so that it's more cross-platform. So it's really just these spherical photos wrapped up in a bunch of JSON that control how it's displayed and being able to toggle the views. And the idea was to create something that was super easy to produce. Like two-click two-click easy to produce that we could give to somebody who has no GIS experience, no VR experience, and let them start actually looking at, getting inside the 3D data. And it's different than just the straight up 360 photos, right? Because it has this location aspect to it, stores multiple locations, right? It's different than kind of the runtime stuff that Adrien's going to talk, because we're not consuming GIS data directly, really. We're creating a rendition of that data and displaying it. It's not like the gaming engines like Unity, because we don't have that 6 degree of freedom where we can walk wherever we want. We've pre-selected the places you can go. And it's not like the HoloLens, because it's monoscopic, not stereoscopic. So there's no close field of depth. So it's a little bit different, but very cool. Right now it's an Esri Labs project. So if you go to the early adopters community, you can find it and you can sign up to download it, add it to your Oculus account, and then it'll show up in your library. So definitely I recommend taking a look at it. So I wanted to walk through what it takes to actually create one of these things really quickly, just to show how easy it is. So this is City Engine. I've got a scene. I just grabbed the transect scene. I can go to a observer location, so I'm going to drop myself into a T4. One of the things we added was this 360 look tool, so you could see kind of what it was going to be like when you exported it to a VR experience from that perspective. I'm going to go back up to the natural view here. I want to add another observer location, just looking down on it for reference. So create a new bookmark. That'll be another observer. Okay, so now I want to create my 360 VR. I export a 360 VR experience and I get this little interface. It's giving me all the different perspectives that I can export from. Here's the one I just added, the perspective view 1. Then it lets me to customize and add multiple scenarios, and inside a scenario are the layers that I'm going to see. So what I'll do here is I'm just going to copy the buildings. Let's make a different representation here. We'll do these buildings by usage. Export it. Let's see, and then add a second scenario. And then click Finish. So it's going to go in the background and render and create those spheres, wrap it up as a 3VR. Once I have it as a 3VR, I can just right-click on it and save share as, and then push it directly to ArcGIS Online or Portal, and then share that with people in my organization or share it with the general public. So it's very, very simple and easy to create. So set the viewpoints in the 3D scene, one-click creation of the 3VR, and then share it, and I'm done. So it's created from City Engine, stored either locally or stored on ArcGIS Online. When I have it in the viewer, I actually download the file, so it becomes local and it's disconnected. And so now I don't have to download it ever again. So it persists itself. So I wanted to touch on a couple other examples of the way we've seen people start to use it that are a little bit more out of the box, outside the box, I should say. So this is the one that's actually being passed around. This is a building information model. And in this case, what we've done is we've split this. Instead of having scenarios, we have different states of the building. So I can strip off all the walls of the building and see through and look at all the infrastructure that's inside it, such as the yellow is electrical lines, the brown is HVAC, there's some blue pipes for water systems. So this kind of gives, it's a very different use of this scenario capability to allow people to control visibility and actually look through shapes. Here, let's strip it back down to just the HVAC system. So, you know, being able to create multiple rooms or multiple views and allow someone who is working in facilities to turn off the walls and see any infrastructure that's behind the walls is one way that this might be used. Another quick example. So this is a little piece of urban street scene. And in this case, again, just using it as a visibility control, rip off the ground. Actually, let's rip off the streets, right? So we can look at the subsurface utilities at a specific, that are underground at a specific location. So it's not just urban design. There's a lot of different ways that it can be used. And people are using it with data that I actually wasn't expecting to see examples so quickly. They took a integrated mesh, which is one of our I3S formats, converted it into an object, and then brought it in and published it as a 3VR file, and then shared that out. So this is a user example. It's pretty cool to see people starting to blend all the 3D capabilities. Okay, where is it going? So this was done as a labs project. We're going to productize it and turn it into a product that we release and support. We're going to make a web app for that VR experience, so it can be more cross-platform. We're going to keep the simple web app for just on-screen viewing for QA/QC and for people who don't have a mobile device. We're looking to add support for importing 360 photography, so you can add that to your experience. And we want to do some refinement in the way you can manage navigation, so making certain views visible only from certain other views. And then in the longer term, there's other things we think we might be interested in adding: measurement, pop-ups, some depth information, and then maybe moving on to video and animation. But so it'll continue to evolve over time. Okay, with that, I'll turn it over to Pascal to talk about moving it into gaming engines.
Yes, so thank you, Eric. So yeah, we saw now the mobile piece and this actually, we did this also using Unity. And and now I'm going to talk a bit more about Unity, and especially how you can use CD Engine. CD Engine is kind of our main tool to bring stuff into Unity. Like if you have some GIS or file geodatabase, etc. Via CD Engine, you can bring in the stuff to Unity. So first, what is Unity? So yeah, Unity is a game engine, as you might know. So it means it's all about nice, good graphics and about interactive graphics in real time. And it's for cool thing is the personal version is for free. So I think and then the pro version is $35 per month, and the plus version $125 per month. And here you can see, like, you can really use it for world building, for obviously for game making, and everything in there is like you have APIs, you have playable objects, game objects, and everything, and yeah, and there are actually, and the biggest thing with Unity is that it is actually relatively simple to use. So here's the editor, and typically the stuff looks simple, but it's actually we don't want to say that it's easy. It's really like it's not so easy to then actually really do stuff in there, and yeah, create these games. But with Unity it's fairly okay. Like there is, for example, Unreal, which is much more complicated to use, but has nicer graphics. So, and the biggest thing with Unity, the big advantage of Unity is actually then it's multi-platform. So like every platform, so we can do something and then you can publish it everywhere. So that's why Unity is really the go-to tool basically for VR and AR. And so I'm going to very quickly now explain what are the best like real practices, how you bring the stuff in there. We will publish this then maybe as a blog or something, so that you actually really see the details. So here is, so in CD Engine, when you have something open in CD Engine, you can import stuff, of course, in CD Engine, or you can create your environment there. You use FBX as format, so FBX is the format of choice, the best one. And there what's important is activate texture atlases and embed textures. What you then get is one file out of CD Engine, and then you can just drag this into the asset folder, in the project folder of Unity, and from there you drag it again into the scene, and then you have it. It's really that simple, and it's actually, yeah, it really works well. What you now have to do is you select the camera and you move the camera into the center, and now let's say you sit on a computer with HTC Vive. So if you have installed an HTC Vive on your machine, then what you need to do is you go to the project settings, you enable virtual reality support, and then here you see you go here plus, and then open add OpenVR on top of Oculus. Per default, there's only Oculus in there, and next thing is you have to press play, and then you're in. Then you can use the HTC Vive, and you're in your 3D model with the HTC Vive. So means, as a developer, you're typically then you're looking in here, and while you're looking around in your Vive, you see the in the play mode, it's the window here also moves the camera. So next thing is some tweaks. We are not sure where the bug is, if it's Unity or us, but we need to make a scale factor of 100. Another thing is Unity thinks if something is transparent, it thinks it's glass. In our case, it's mostly not the case. Like we don't have glass C3s. So change there the rendering mode. But these are the two core things, and then it looks good actually. So now you have a good-looking scene in your Vive. So now you need to add locomotion. So it means you want to move around there. Therefore, we recommend to use the Steam VR plugin. So you get that on the asset store of Unity. Import this, and then you replace the main camera of Unity with the one provided by Steam VR. Then you add the teleporting game object. And then afterwards, what you can do is now you can drag teleport points onto your scene. So it means, see here now these blue dots here. So these are now my teleport points. So it means now again I press play, I look at the Vive. Now I can use the hand controller, and now I can see there where I placed my teleport points. I can now select them, drag, then I go there. So that's the kind of one part. The more complicated part is teleport anywhere, and this is really well done in Unity. So all you have to do is really you go and select your original asset as your FBX and activate generate collider, and then it creates you collision geometry. 3 years ago that was a major problem, but now stuff just works. It's awesome. And when you have that, then you select in this case, for example, you select the streets, and now this is I'm not sure if that's wanted, but you basically need to copy paste this and then assign the teleport area script. So it means when you hear from your Steam VR plugin, you drag this here, and then it appears here as teleport area script. And once you have this, again, you press play, and now you can, with your hand controller, everywhere on the street, you can aim and then go there. So with this, you can move around now in the whole city. And Yeah, so that's kind of like the very basics. Of course, there are many things in Unity which you can do, but the very core basics are these. So, and with this, I give it to Adrien.
Thank you, Pascal. So, I'm Adrien. I'm working in the ArcGIS Runtime, but before showing you the runtime, I'm going to show exactly what Pascal just talked about running live. So, Pascal showed how you can use City Engine to export your FBX into Unity. You can do the same with another of our application, Drone to Map. You can do the same process. So here I just basically have my Drone to Map data just put inside Unity, and it's set up for HoloLens project. So I'm going to try to share my HoloLens view of it, and hopefully it will work. HoloLens is an amazing device, but it's not completely made to be shared. So you see that we have a magic projector with a table on top of it, and I can get closer. The advantage of AR is I can actually know where the step is, and I'm not falling off the stage. And you can see me interacting with the Drone to Map data just using my fingers. And you can see it's really imagery made from a drone. You can really recognize it.
Yeah, we lost you.
I guess you get the idea. So I'm working in the runtime, and when we're thinking about trying to put some AR, VR, MR functionalities into any of our existing products, the runtime is a perfect candidate. First, because we run 3D natively on all the supported devices that use AR, VR. So it could be on Windows for HTC Vive, Oculus Rift, Windows, all the new Windows 10 headsets that are coming up. And we also run on iPhone, Android, and Windows 10 mobile, so that's perfect for the Google Daydream, the Samsung GearVR, or just a simple cardboard and similar hardware. Plus, with the runtime, you have native application, which means as a developer, you can actually access all the sensor of your device and burn that into your app. So it could be the external controllers, it could be the sensors controlling the camera, looking right and left, and move your head. You have access to all those because those are native applications. And we are integrated with the ArcGIS platform, so you can consume your data that you have right now if you're a user, an Esri user. And we also can work disconnected. We have a lot of disconnected formats, and a lot of time you just want to show something like we are right now, passing that VR experience around. We don't really need to be connected to the internet. So what I'm here to announce is that we're going to try to have a full ArcGIS runtime solution for VRJAR, and we have a private beta that it's coming. So what it is, it's basically taking our existing runtime SDKs. So if you're not familiar with our runtime SDKs, it's basically you can create your own scene, taking your own data, your own layer, and place the camera the way you want, and then you can look at geographic data that can come from any of the ArcGIS platforms. What we're going to add is two things. We're going to add the stereo display. So if you already looked at what the actual screen looked like when it's inside one of those Google cardboard or any of those Samsung glass, you will see that really barrel effect and the two-side renderings that I have here on this image. And the other stuff we're going to add is a transparent background, making everything transparent in your scene, except maybe the layer you're interested in. And that way you'll be able to, let's say you want to adjust the data of your pipe, and if you have your GPS location and you use the sensor on your phone, and you'll be able to look at your pipe like they're going under your current terrain. The advantage of it just adding those two functionalities, of course, there's a lot of technology behind it to be able to leverage those functionality even on really small devices. Is that it's really easy to add an immersive VR or AR experience to any existing 3D runtime application. So I wrote that slide about 2 days ago, and I was like, oh, maybe I should actually show how simple that is. So what I did is I took the application I showed on the plenary, where I was in Yosemite, and I just started looking around. So for people that didn't, see that presentation, I'm just showing exactly the application I'd show on the main stage. Now, what I can do is, by just adding one line of code, I'm going to close those applications running here. Just adding one line of code of my scene view, all I'm going to say is now you're going to set the stereo mode of my scene view to be stereo mode double side, so basically the one with the barrel effect that we just showed. And that's all I have to change. And now, and actually that's when I actually press the button. You can see in the code here, that's actually when I check, when I click on the compass mode. So if I go back to what the application looks like now, don't know why it kicked me out, but anyway. So I have exactly the same application I had before. And now, if I actually switch to that button, you see that I have exactly the same capabilities, except that for you, it looks pretty bad and make you sick. But for me, I have a pretty cool experience. Oh, I'm scared of falling now. So the goal is really to be that simple, to take your existing 3D application and be able to right away switch to an immersive experience. So all the functionality of a traditional 3D runtime application are available, and we have a bunch of APIs to connect to the camera and make you do a lot of things with the camera. The challenges of developing an immersive environment using the runtime SDKs, well, the runtime are SDKs, so it's a developer product. So it's not that easy to write, a pure VRIAR app just using an SDK. One of the things is, here I have a really good experience on my Android device. If I wanted the same one on an iOS device, I would have to rewrite the device sensor data and connection to the camera and things like that. So each hardware, you will have to rewrite the connection between the hardware sensors and the runtime SDKs. And there's no developer framework really to write a real good VR UI. So that's why gaming engines are really good at, but for the developers out there, doing that in Visual Studio is not that easy. So we're looking at a private beta program for hopefully the Q3 of this year. The first thing we need is to release the update run of the runtime. So we have a new version 100, and the version that's coming, 100.1, is all about supporting mobile platform. Obviously, when you want to run VR on phones, you need to make sure that a simple scene renders well on phone to be able to, after, render actually two scenes side by side to get that immersive experience. We're probably going to limit it currently to the runtime SDK for .NET. That has the advantage of hitting all the platform. Windows 10 with WPF also for all the Windows platform. But using Xamarin, then you hit iOS and Android. So I'm just going to show you what a typical .NET application look like, where you have here on the side a project for Android, a project for Windows Desktop, so WPF, a project for iOS, and a project for the modern Windows UWP. But they can all share most of their code into a shared project. So it's a really good way, if you haven't learned about our .NET SDKs, it's a really good way to write for several platforms but still share most of your code. So actually, that's a really, really simple app that I have here. But just to show you that it runs on Android, but it can run anywhere. Apparently it's a simple app, but it takes a lot of time to build for some reason. Yeah, it is. Typical simple app, I just have one base layer, and if I click on the map, it goes to a different bookmark. Cannot make simpler than that. And once again, I'm insisting, because it's that simple, that if I want to make it with a stereo display, I just set the stereo display to side by side. I rerun exactly the same application. And now you have the side by side, except that there's an internet connection issue. Oh, here it is. And same app, but now I can run inside the Google Cardboard, the Samsung GearVR, or all those Oculus Rift, for example. If I'm connected to my computer, that's what the Oculus Rift will look like. So that's simple, but it does put on you developers the job of connecting the device sensors to the runtime SDK. So what else? So we showed you what's available today with 360 VR and exporting FBX from City Engine or from Drone to Maps. That's available today. We just show you what's coming tomorrow with that full ArcGIS runtime approach. It's not the only solution we're looking at. We're looking at as still using the ArcGIS runtime, but be able to plug to some gaming engines. So basically, the runtime will be used to bring GIS to existing gaming engines. And that way, you can actually build inside Unity, kind of what Pascal was showing earlier, how you can build a gaming type engine. So it's really easy because it's with Unity or Unreal Engine, it's really cross hardware for VR and AR development. You don't have to reconnect your sensors and all that. That's all done by Unity. Each time there's a new hardware coming in, Unity will just be in charge of taking care of that new device. And there's a really good UI for it. And you will be integrated with the VRJAR community, so you will actually be able to have a lot of support on what you're trying to do. So I'm going to show you quickly what we mean. If this time I might be disconnected after a few seconds again, so I'm going to start the app first. Problem with HoloLens is sometimes you don't know where your app is. Let me put it back on the projector here. Yeah, here we are. And let's see if I can get at least 30 seconds of showing you what I mean. So I'm here looking at terrain data and imagery, and this time I'm actually not disconnected from the ArcGIS platform. Those are directly taken from ArcGIS Online. Show Paris. Froze before Paris, I just wrong. Maybe you can be in charge of going back and just reopen it. Sure. So once again, this data is not exported at any point. We're actually doing a direct transcription from ArcGIS Online and pass it at runtime to Unity. So we are connected to the platform right now. And one of the things we can do too is we can actually use the ArcGIS runtime. And if I click somewhere, I can actually get the address from that place using the ArcGIS runtime. I will do the request online to get the address of that particular location. Waiting it for it to come back. Hopefully you've seen it. It's not coming back. There it is. So you can see now that I can click anywhere, and it will actually use the ArcGIS runtime to request that address and display it. That's all happening at runtime inside Unity. So that's kind of what we have as a proof of concept, that we can be connected to the platform inside Unity at runtime. So what we need from you is your feedback on everything we just showed you. First thing will be, of course, by filling up the session survey and making sure that besides the glimpse on the HoloLens not displaying, you had a good experience today. We also, for the beta program, if you are interested of joining that private beta program for the runtime, please talk to Rex over here, or send him an email, or tweet, or anything you want. Exactly, just send him his way.
Just contact me. We'll chat about it. We'll talk it through, and we'll see what we can do about the beta program.
But we are really interested on trying to see what you guys want to build regarding VRJAR, how important it is for you. It's kind of a new technology, even if I've been there for several years. People start adopting it outside of the gaming industry. So we're really interested of having your feedback on all of what we showed you and what you can do with it. So in the name of the four of us, thank you for being there, and hopefully you enjoyed it.